Hello? Oh, great. So I'm Asad. Nice to see you here. Welcome to my talk. And my name is Jarek Ratajski. I work for this company, CSS Versicherung, or you call it CSS Insurance. We don't insure style sheets, but your health in Switzerland. That's my email, that's my Twitter, so please tweet if you have some issues or you like the presentation. Don't tweet if you don't like. And I'm a developer, wizard, and an architect. I live in Lucerne, in Switzerland. I work there. If you would like to spend your life over the lake, between beautiful mountains with a perfectly clean air, yes, we are hiring. You only have to know German. I think it's a trade-off you can stand. OK. But it's not about me. This presentation it will be about Ratpack. Who has heard about Ratpack before? Oh, cool. A couple of people. What? It's a group of musicians and actors made by Country Really? Yeah, really. Oh, how cool. Then maybe I will switch the presentation. I don't have any music, but maybe I will try. OK. Who had tried Ratpack somewhere on production or at tests or so? More than Hello World. Oh, my God. You see nobody. OK, cool. So it's good that you are here. It's really worth that. It's something that is useful. So early in the morning, for me it was a morning, 10 o'clock, I was bashing Java EE, Spring, and all those big frameworks that we are using. And it was basically why I hate it, why I don't think it really answers the problems of 21st century. And right now, this part is a positive one. I will show something that I think is enough useful. Of course, it's not perfect, but it's quite OK. And you should generally know it. So the content will be a demo, very useless demo. Then what is non-blocking architecture? Who knows what non-blocking architecture has heard? OK, cool that you are here, because cool, those that are not and those that are, maybe you can fix something, or if I am wrong, or even add something, you are welcome to add. Then I will do some real demo, so more useful. And then I will just describe the solutions and some, I would say, outcomes from the projects and my experience with Ratpack. And this is, of course, not Ratpack manual, what I am presenting. If you are interested in Ratpack manual, what you do, you go to the page ratpack.io, and everything is there. So what I am going to present today, it's not this page. This page you can do on your own. You can read it. OK. So why Ratpack? It's like a couple of years ago, I was very curious. I wanted to know Scala, because people were saying Scala is a cool new language. And then I tried to do, I typically don't just learn language by just learning a book and reading a book, and then just, I have to try on something. So I tried to write something with Scala, and what I was doing web servers, like in Java. And then I was analyzing how people do web servers with typical RESTful servers with Java. How do they do that? I instantly realized something. They don't use Spring. They don't use Java EE. They just use plain language, Scala. And it works. It's small. It's fast. It's good enough. What is even better, they don't really have that many null pointer exceptions. If something is written, it works. I really love that part in Scala, but I was wondering if it's Scala specific, because a command at the end of the day, it's just JVM. Can't you write that the same way in Java? And then I realized, of course you can. By the way, who has used Node.js, for instance? But many of you have heard. So there is a Node.js. That's the different story. People are using this funny JavaScript, but they are very efficient. They don't use any enterprise frameworks, just very small server. If you ever see the code of Node.js server, it's just a couple of lines, and it's there. And then it's very simple. No complicated dependency injections and everything. So it just works. It's just code. You can test it. How cool. OK. So on the answer to the question, can you do that with Java, I was surprised to find out that, of course, you can. And there are people that are doing it for years. Just nobody listens to them. And so I'm the guy that took a look at this world, alternative web servers for Java, and I'm going to present you. So first you will see something that is the second most useless Fibonacci implementation. It's very important because I have the most useless implementation of Fibonacci that I can present. It's not for this presentation. I am doing it on the function with a functional way on some other presentation, but it's not today. So today you see the second most useless implementation of Fibonacci, and just take a look at it. So just a moment. I have to log into my. And this is, I will not be doing live coding. We don't have that much time for my spelling mistakes. So one cool thing, you start with a Ratpack with a main method. It's just, who has recently written a main method in Java? Not that many of you. You know how it feels like, it's like you take a breath when you spend, minutes under the water writing these enterprise servers, and in one moment on your life, you just write main method, public static void main. It's like, oh, cool, it's a fresh air everywhere. It feels like that, really, try it. And then maybe the first line is not important. This HTTP client, it's something I need later. It's not really important for a Ratpack. It's just for this presentation. But take a look at this line. Ratpack start. Exactly the way you start server. It's a library. So first thing, Ratpack is not a framework. It's more a tool, and I even call it library. So it doesn't say to you, I will be using you like that. No, you say, OK, Ratpack, you are my slave. I'm going to use you like that. And you are in command. It really feels better. So you say, start server with a server configuration on port 5050, not in development mode. It doesn't really matter, but it's about errors. And with one thread. One thread is cool. Who knows why one thread is cool? OK, I will show you later. But of course, you can use more threads. And then that's the first part. Only configuration, by the way, you can skip it. It is more or less the default configuration, so I didn't have to write that. Then comes the real part. So I'm going to do a server that is presenting Fibonacci numbers. So under the prefix fib here, I'm registering a function that answers to get, fib get, HTTP get. How simple is that? With a number n after that, so it's just some kind of number. And what I do, so if this request comes, I write here a function that answers to that. You may think this code is a little bit verbose. I'll show you later how to do it better, more structured. But for a moment, just for simplicity, we have one main function. It's just all in this function. So I'm parsing this get, this n, and I have it. Then, in case this n is less than 2, I'm rendering 1. It's like in Fibonacci, the simplified version. And then, otherwise, of course, what I should do otherwise? I will be doing it recursively. Of course, so I take Fibonacci from n-1 and n-2, and I will just use it. But I will do it in the most stupid way possible. I will call the server again. Really. So, in this line, I'm calling with server with n-1. What you see here, it may be interesting. It's here something called promise. What's that? So this call here isn't really, at the moment, in Java, enters this line, this thread processing this is not blocked. It only means I'm going to call this, and once and the HTTP client, the thing at the beginning, makes this call and gives me a promise. And in this moment, you should know that it's, of course, the good solution. I've observed it. People always choose other people that give promises. You see that. So it gives you promise. So, of course, you should choose this solution. So it gives you promise. What is a promise? Promise is a promise. It means I don't have response for you right now. I will have it later. I promise. Once I have it, I will tell you. OK, so we have this promise of the response. What do we do with that? So we say, OK, I really need from this promise the number. So I have this received promise. what I do, I parse response to get promise of long. And by the way, in this moment, I don't have long because I'm depending on promise, which means that somebody promised me text with a Fibonacci number. So I can pass further. That's right now my code, let's say. Having this promise, I promise that I will have long. OK, it's like chain of promises. Somebody promised me, so I can promise someone else. How cool. That's the chaining of promise. OK, and we have solved the problem of n-1. We do the same with n-2. So we call, and in this moment, very interesting thing, because this program doesn't stop, doesn't wait for this response, and it means instantly it calls the Fibonacci n-1 and instantly calls -2. It means those calls are done parallelly, concurrently. And then I get the second promise, and again I parse it. Done. OK, done. Almost done. Almost there. What I do if I have those two promises? If I get those two promises, then I can combine them, and that's this method then here. And then I can combine it in the promise of the response. So in fact, in this moment, I have promise of the Fibonacci first and Fibonacci 2. It means I can give, and this ctx render is rendering a value, final value, but all with promises. OK? So what this code does is simply operates on promises. What is cool in this code, it never stops. It means this one thread processing it will just go, no matter how slow the server is. It just go, will pass the promise to render, and no problem. So let's try it. OK? By the way, that should be very slow, and it is kind of slow. So let me check this. So Fibonacci from 10. It's like, oh, in response is pretty quick. I hope you see this. Fibonacci of 10. So maybe Fibonacci of 15. Not more. Because you know, with 15, then I make 2 other Fibonaccis, then 2 other. It explodes quickly. So I am really bombarding the server at the moment. But you should see here is how CPU is used in this computer. It's not really that much used. So maybe I'm doing Fibonacci of 18. I got the number. OK, you see it works perfectly. It works. So maybe now I will show you why it's that cool. Because I will do the alternative implementation. I will do an implementation with Spring Boot. OK? It's more or less similar. I didn't really take care to be exactly the same solution. And it looks like more where I have it. It's here. So request mapping Fibonacci, fib. Then the difference is I'm using request param, so n. And I even prepared this code to be a little bit asynchronous, but it's not really, because here I call, so I do 2 calls parallel to Fibonacci n-1 and -2, but I wait for the answer here. OK? I just wait. This get here from completable future means I wait till I have this answer, and then I render it. OK? So I can start this server. Just a moment. OK. It starts. OK, Spring started, and then I will be using that. So the port is, I think, 8080 here. And just help me if I make something wrong. Localhost 8080, that was fib, n-1, n1, OK. Maybe n10 works, n13. Remember, this is very bad implementation. You see, it's kind of slow. It's slow. It's slow. It's 13. You know, it will wait maybe 1 minute. Who knows why it fails? Why it's so slow? Yeah, exactly. Thread pool exhausted. So of course I can make more threads, but how many threads do I need? 1,000 at the end to, for instance, call Fibonacci 20. So with Ratpack, with this non-blocking architecture, I could use 1 thread and have it calculated really quickly. With this approach, which is, by the way, default probability that you use, that's not a Spring problem. That's a problem of servlet architecture. So Tomcat, whatever you have, WebSphere, JBoss, you will have this problem. And by the way, I had even this problem on productive system. Whenever you do some recursive call, it might not be direct, you can get into this problem. OK. So there is a problem of this blocking architecture, and we've seen that this no-blocking architecture, oh, you see, it's not even rendered. So maybe you may ask, why one thread? One white thread is cool. I will answer this question later, but before I answer it, I will show you some very bad benchmark. Okay? So what you see here is not a real benchmark. It's really hard to do a good benchmark, but I will do some, I would say, showing something benchmark. You just don't care, please. So AB, who knows the AB? That's the very simple tool from Apache Benchmark that what does? It will call 2,000 times Fibonacci of 15, maybe we'll do smaller number, 13, with 250 concurrent calls. It means 250 concurrent calls. This, poor server that has one thread. Let me show you if it works. Oh my God, we are doing something. Oh, doesn't really work in my opinion. Or did I block something? Something is really, maybe I did too much at the moment, or I blocked the server. Oh, 200 requests are completed. OK, you see it's kind of slow, but it works. 2,000 requests, yeah? With, OK, we'll wait a little bit. Maybe I did, you know what? For this moment, I will skip to, I will make it slower. I will wait for 1,000 requests, OK? Because it's not warmed up machine. I don't want to force you to wait that much. We should see the results faster right now. OK, well, slowly, slowly. Just let's wait. Ta-dam, ta-dam. 13. Oh my God, it's slower than 200 requests. We'll just see how much time it takes to render all this message. It's Fibonacci from 13. It's already, this implementation of Fibonacci is really bad one. That's why it's always slow. Especially, it's done by one. Oh, I will show you something funny. So the server is completely bombarded right now, but maybe we can use it. So Fibonacci of 10, you see it's slow. But it responds. It's always a response. It's not really like saying, oh my God, too many requests, denial of service. Even though it's bombarded with and it's implemented that bad, it still works. So we will should see the answer more or less. OK, so you see it's kind of slow. Its median is like 16 seconds because it was very bad implementation. So we'll just maybe, OK, let's take a look at this number, 99%. So we'll change something because this is Java. It's not Node.js. So what can we do is we can maybe, we can, in fact, use more threads than one. You see that one thread was OK. So maybe I would use 4 threads. Why not? So let me restart. This server is right now restarting, so it will take some time. It's already restarted. By the way, it's so, I know one thing. I had it in the debug mode. OK, no worry. So it's very bad benchmark at this moment because I have this server partially on debug mode, but I just forget it. So right now, I'm doing the same benchmark with 4 threads. Is it better or worse? Who thinks it should be better? It's all warming up. So you see it really responds. It should respond a little bit quicker. Ta-dam, ta-dam. Oh, come on. And you do it. You do it. Well, but it's still not even completely covering my CPU. Why? Who knows why? Why the CPU is not exhausted, really? What? Yeah, so basically, it's because this implementation of Fibonacci, what it calculates, it sums 2 numbers. It's not that much more work for CPU. What it really does is does heavily I/O. And it's something that, number of threads doesn't matter. So you see that with 4 threads, I was a little bit faster. It's not that much. So I will spare you this time, save you this time. But basically, if you do 8 threads, you will be a little bit faster. But if you do 100 threads, you will be slower. Who knows why?
Context switching?
Exactly. So this computer has basically 8 logical cores. 8. Even 4 real cores. It means that whatever you do, you can't do more than 8 tasks at a time. So if you had 100 threads, of course, it doesn't mean it makes 100 things concurrently. It only makes maximum 8 things concurrently, and not more. So if you do it with more threads, you only lose, because you lose on context switching. I will show you later this week. OK, so we did some very stupid tests. So basically, the problem of Spring, of classic blocking architecture, one request, one thread, is that if the request takes long time, it means the thread is blocked. And of course, you never give infinite number of threads, because if you have 1,000 threads, first of all, probably your even OS will corrupt because it doesn't support that many. So you have to limit that. So every server has a limit, maybe 100, maybe more. So there is a limit. What happens if you have like 100 threads limit and all of those threads are busy? Comes request number 101. Then it goes to the queue. So it simply waits till one of those threads above are free. The problem with this recursive Fibonacci version is all those are busy and are waiting. Then comes request 101, and it will be free once one of those above is free. But none of those above can be freed because none of those below can end. So it's like deadlock. So it's the problem that may happen, and in fact, I had this similar problem, of course, not with Fibonacci, but on a productive system. So you've seen for a moment that non-blocking really rules, and one thread really can do a lot. 250 concurrent requests. Even you can, this was very bad implementation of Fibonacci. If you have something simple, but even with complicated calculations, you can do with one thread even thousands of concurrent requests, and the server will work. Maybe it will work slow, but it will work. And you've seen already the basics of Ratpack, how to configure it. It's very simple. Ratpack start, prefix something, and then. So basically, that's it. But OK, we'll then cover a couple of things more detailed. So the essence of non-blocking architecture, for those of you that have seen that, what is this? It means we don't block. It's very simple. Non-blocking means we don't block. So maybe typical case, right now, we have a service. We are building a service that needs to do 2 things, needs to check 2 things. We can give response to user once we first ask some HTTP server, so additional service. This server should give us response, and then we call database. This database will give us some response, and then we'll give some answer to the user. So 2 things to do. And maybe those are dependent on each other, so we don't do them concurrently. We have to wait. So how it typically works with, imagine we have 1 thread. So what happens? 1 thread. This thread on a server gets request from user, request 1. So what this thread does, OK, I have to parse it, because maybe the request has some information about the user. Once I parse it, I can call HTTP server. So I call the HTTP server, and in this moment, I am done. So maybe then I can do the request too from other user. So again, I parse it because I know at this moment I have to parse the data. And I call the HTTP server because I'm busy. I know what to do. Once I call HTTP server, there's nothing more I can do. I don't wait. I'm done. And maybe while I was doing that, parsing of the request, response from HTTP server number 1 came somewhere asynchronously. It means I get it as a next task to do. So maybe this time, for the request 1, I have the response of the HTTP server. So I parse it. And then right now, I can call database. I'm doing that. All the steps still calling the database. And in this moment, I don't wait for the database answer. I'm done. And maybe while I was doing that, answer from the HTTP call for request 2 came, HTTP server. So I can do another task. You see, it's the same story. I parse it, I call DB, and I don't wait for DB. I'm done. So maybe in this moment, I can process the 3rd request from the 3rd user, because it came as a task to me. And while I'm doing that, maybe DB answer came, and maybe this time first for the request 2, then for the request 1. So I won't know what to do in this moment for request 2. I can process DB result. I am busy with that. And in the moment I know what to send to the user, I send the response. I'm done. So, and I'm finally done. It's done, done, done. Then maybe the same story with request 1, and I don't cover the request 3. Where is the win here? Is really, you save on context switching. It means this thread is constantly busy. And for instance, while it is processing, just look at this one thing at the beginning, at the end. While it's processing DB results, it had response, it sends it. What happens if you had 100 threads on a 4-core CPU? Maybe you are in the same stage. You are a thread, you have a task to do, you have all the data, you prepare response, and in this moment, OS scheduler says to you, oh, you wasted already too much time. I have to switch you to some other thread because there are 100 waiting. So I switch you. So you are almost done. You are about to send to the user, and you are switched. What then happens? CPU has caches. And in fact, what is at the moment the biggest problem of CPU is loading these caches and unloading these caches. It takes time. So you had everything in cache, but it's wasted because another thread comes, and it has different data. All your data in caches is gone. The other thread has to load it. It takes time. It's this context switching. And maybe it will do everything. It will be almost ready, this second thread, to send data to user, but then comes OS scheduler and says, thread number 3. So it means with a blocking architecture, and if you have more threads than physical cores, you are potentially wasting a lot of time on a context switching. And by the way, non-blocking architecture also looks from a different perspective like this. You have some processor. Just take a look inside. That's event loop. And this processor accepts tasks from the queue, just one by one, and does this task from the beginning to the end, like a good worker. I take everything, I do what I can. In moment I, for instance, have to wait for someone else's job, I don't wait. I call someone asynchronously, and I go to the job number 2. And this guy is responsible to, once he gets response, to send me asynchronously new task to my queue. It's very simple architecture. It works like that. By the way, in JavaScript, it works like that. Event loop is all the same approach. So at the end, we have a lot of tasks that appear to be done concurrently, done by minimum number of threads. And we use CPU caches very efficiently because we do tasks from the beginning to the end. OK, so by the way, that's about latencies. Check this diagram. It's quite known in the network later. And see how much it costs to do context switching. It's really incredible. So if you want to know more, there are blogs and talks about mechanical sympathy. A lot of people are covering this talk. I'm not today, so just read about it. So, but in order to do that, what you need is asynchronous I/O. And basically, if you think about network, you have it in Java. If you think about files, you have it. If you think about NoSQL databases, mostly you have it. So you have CouchDB, Mongo, you can call them asynchronously. You can say what to do once the response is done. But there is a problem with SQL. SQL, and especially JDBC, is blocking by the nature. So SQL doesn't have to, by JDBC it is. So what's the solution for that? Who knows the solution? OK, I will show you some simple solution later, but basically there is no perfect solution. There are only workarounds. So, and by the way, it's not that when you do non-blocking architecture, you are perfectly fast, you instantly are 100 times faster. And don't promise it to you. OK, I've shown you promises, but this thing I don't promise you. My experience is that it means you can tune your performance better, you can really debug it better, you can benchmark it better, and yeah, controlling is easier. But performance, you may have better, it's not guaranteed. There are some examples when switching to non-blocking architecture even gave, at the beginning, slower performance, but typically it's not worse than classical. So it depends on the task. So, but my opinion is that not the performance. The performance sells well. And this possibility is really something you can sell to your managers, but from a developer perspective, what I think it's making the difference is the clean code. Because if you work with Ratpack, you can avoid one of the biggest problems that I see in Java world. So mainstream Java web frameworks, what I think are horrible, because they rely on magic. So things that are done behind, that you don't control, that sometimes give you null pointers, and you don't even know where to put debug line. Because if this bin is not injected, where do you put debug line? OK? So what is magic? It's basically runtime reflection, aspects, intercepts, so thread local. Who knows what thread local is? It's a horrible thing. You know that global variables are horrible. It's worse than global variables because it's global for thread variables, so you can't even debug it easily. Because once you run in the debug mode, you will see different values. But OK. Class loaders, class scanning, which make, for instance, I had to fight a lot in my company to change our Java versions to Java 8 because we had a lot of strange tools scanning our class path that couldn't understand jars compiled with Java 8. It's funny. So annotations that are processed at runtime, so you forget one annotation or use the wrong one, and your transactions do not work, etc. And all your classes are beans. So that's basically magic, and I think magic, I see it every day, ends this way. So if you rely on magic, you can save your time. That's a nice hack. OK, so my opinion is that once we have lambdas in Java 8, we can avoid a lot of this magic. So there is a great talk. Again, sorry, I have to refer to other talks. G composed with F patterns from Mario Fusco, where he describes how to do differently with functional approach, with first-order functions, high-order functions, so patterns. Yeah, and then my talk from this morning on annotations, where I was bashing this framework, and there is a funny page, Annotation Mania. But I'm not covering this. What I will show you right now is a Pong. What is a Pong check, basically? So for me, it's like in 1973, first time group of developers, they've written Pong application for some microprocessor, Pong. And it was really a huge thing. That was the first popular game, I would say, Pong. And what I do typically, if someone says to me, yeah, I have really great web framework, you will do everything, you will have everything automatically generated. I ask, can you do Pong with that? Typical answer, no, it's only for business forms, etc. So my answer then is, yeah, if you can't do Pong, it means, for sure, this framework is not ready for year 2017, because it's not even ready for 1973. So if I learn a framework like Ratpack or whatever library, I check if I can do Pong. So I did already a couple of checks, but I am presenting you the Pong check with Ratpack. Proof that it is ready for 1973. OK, and it's that. So I'm starting the server. And it will be a very quick demo. And it's probably the worst version of Pong that you have seen, but only because I'm very bad at doing beautiful things. So I log into server, just a moment. So I have some users. So it's really multiplayer Pong. We can maybe play later together if you would like to. So I have to try with two accounts. Registering is free, but on the other hand, it's only on the local host. So maybe I will create Devox game. I create a Devox game with one player. Then I have Devox game visible with second player. And now I will play. Oh, my God. Now, this is this player. Oh, my God. You see it works. How cool. So the Pong check worked. It's in a web. By the way, the ball moves slowly, but it's only done so that I can really play with that. And right now, because I'm I'm not that fast. I can program in Java. You know, it made me not thinking enough fast to play faster Pong. But OK, it works. You see that? I have even scores, everything. It's great game. And the greatest thing about this, that the whole code is on a GitHub. And it really, you can check. It's here with a longer explanation about architecture and everything. So if you are in doubt how to write something bigger than Hello World, I think it's good enough example how to write something sensible with a Ratpack. It covers from the services, how you write it, till the database. I will address this thing. So just let me go quickly through these features of a Ratpong that I've written. So first, Ratpack, about Ratpack. It's a netty-based framework. Who had heard about netty? Yeah, so it's quite low-level I/O library framework for Java, and basically everybody says it's cool, it's really powerful, but it's very hard to use. So Ratpack is just utility sugar on top of netty to write easily servers. And it uses Java 8. It's great because we can use lambdas easily. And direct with Ratpack, with netty, you can do, but with Ratpack, it's not for just this. It's only for HTTP. And by the way, it doesn't really have HTTP 2 yet. It's only planned. So we basically can do HTTP and WebSockets. Just it. And this is the main part of Ratpack, routing. For instance, I say that games, if someone does post with ID, it means I'm joining the game. So posting game with ID of game is joining the game. Or otherwise, all other things like I can list game with get, or if I don't put this ID, I can create game. So there are different methods here. And it's, you see, it's just done with functions. It's a recipe. How do I compose my REST services? It means composition. It's not done with some annotations or some XMLs. It means, for instance, I can change it in a runtime, or I can have easily test version, and I can compose that in test version, this thing is working differently, etc. So Ratpack is all about promises. It means we are not blocking. It means we are giving promises. So typically, what it means, if I am calling some service, this service shouldn't be blocking. What it means, service, like this below, like add user, should give me a promise. And by the way, this is a thing I will later discuss. Typical promise in Java you should mark as completion stage. It's a completable future completion stage is promise. And then you typically what you do, you call service. Service returns you completion stage. And then you render it to the JSON. There is a utility method to change this register user status to JSON promise. And then you have JSON. Simple like that. So so maybe you can take a look at this code later. So what is cool about Ratpack? JSON mappings are easy. So for instance, with this game, this is a game state. So every time you look at the game, you have a ball, you have 2 players, you have time, you have game phase, so is it win or not? Then it's with just a couple of annotations, JSON deserialized, JSON creator. I'm not even sure if they are needed. You can easily get, but that's not Ratpack, that's Jackson. You can easily get JSON, or you can parse JSON. And it looks like this. This is easy. So Ratpack with JSON works perfectly. What it also has, what is very cool, I'm not sure why I have this here, but it works with immutable data perfectly. So I am big fan of doing things immutable. Why? Because if you do collections or your classes immutable, so it means without getters, setters especially, getters you can have, then you are very constraining the places that you possibly have bugs. So if you have a bin or object that has in one moment, I don't know, value 2, then for sure it will have this value 2 always. Nobody behind will change it. That's the cool thing about it being immutable, and it's possible to do almost everything immutable. And this implementation of a game, of the Pong, if you check the code, almost everything is immutable. So for instance, what it means if a player changes the position. It means the new game state comes with a little bit change the position of the player. But it's not, it's just a new object with everything. It doesn't cost that much. So if you want to know more, there is a great presentation. There are slides from this that are quite good. Monadic Java from Mario Fuchsko. What is monad? Who knows what the monad is? OK, I will say it's a cheating container. more or less. What is cheating? Because you can do mutations, you can do size effect pretending that you are immutable. It's very simple. And basically, I won't cover it. Go to the Mario Fusco presentation or other presentations. Monads are cool. Let's go back to it's about how you code that, basically. Coding with immutability and monads is just reducing the possibility of errors, and it really works. So if you have configuration, you've seen that configuration of Ratpack was done also functional way. Server config and then some kind of lambda. Why? Because, again, what is great about functions, you can compose functions. So, for instance, I have in this code somewhere where I have default configuration, I have test configuration with something, I have configuration for production with static files, etc. And I can, depending what I am doing, I can compose. So, for instance, productive configuration is default configuration plus static files configuration. It's composition of function. It's really great. It's way better. How could you even do that with, for instance, I don't know, configuration that are statics in annotations? You can't. So this is great. What is the best thing about Ratpack? It's testing. How do you test RESTful services? How do you test them? So the best way to test service, in my opinion, is, I already told it today, is to test REST service. It means we test like that. And Ratpack has some utilities for that. We do have HTTP client. We start a server. Really, we start a server inside of the unit test. We call it with all the headers and everything. And then we check if the answer is what we expected. So this is the typical test and that you write. And what is funny, you may think it's slow, but it's not. Ratpack in the test server typically takes like 10, 16 milliseconds to start. It means you can do hundreds of tests per second, and it doesn't cost you that much. So about security, so how I do security? It's great. I don't configure any XML. I write my security code on my own. So, for instance, with a function composition, that's a thing you can learn from this Mario Fusco talk. Render secure is, for instance, listing game is restricted to only logged-in user. How do I do that? I have method list games. That context is HTTP context. Then I call some utility function called render secure, and I pass what I'm going to do. I'm going to call list games. List game is main function. But what is render secure? I wrote this method, and inside of the render secure, I check if the request has a HTTP header, if this header has a token of the registered user, etc., logged in user. All of that is, in fact, quite simple. You can do it on your own. This is the code with monads. I won't cover it today, but it means it's under your control. The same story is about persistence, more or less. So basically, I am big fan of something. I am not big fan, maybe if you see at my t-shirt, of databases. But I say simply, if you need persistence, there are better tools than SQL or even NoSQL databases. I'm using something that is NoSQL, but forget for a minute about it. But if you need SQL, there is something better than JPA, and it's called Juke. What is cool about Juke, it doesn't use magic. And you fully control SQL. And you know what you are doing. It has nice API, and it's very productive. And how you do persistence with Juke? Like this. Transaction, for instance. I have method transaction, and inside of this method, I say what I am doing inside of transaction. And it's not annotation that is controlling my transaction, it's the code, it's the compiler that guarantees me I'm running inside of the transaction. But you may think, oh, moment, that was SQL call. Is it blocking? Yes, it is. How can it work with Ratpack? So the answer is, it doesn't work well unless you wrap it. And how you wrap the blocking code, that's my recipe. I don't even know if this pattern has a name, but it's very simple. If I have something blocking, I devote one thread to this blocking tasks. And I'm using this writes executor, so executor scale. And simply, every time I have something blocking to do, I simply pass it to this executor. So one of my threads is, unfortunately, I cannot use it anymore for Ratpack. I'm using it for the blocking things. And inside of this, that is one thread, it processes all the blocking tasks one by one. Once something is ready, maybe it sends me a future. I'm not showing it this, but it's possible to use that way. That's a common pattern. And by the way, Ratpack has something like that built in. I'm not using Ratpack thing because default Java has enough for me, but even Ratpack provides you something that you can use for default. But by the way, if you just need persistence, not SQL, there is a cool solution to that called Prevailer. I have talks about it. I like this because it's very simple, and you can still use it. What is great about Ratpack, for me, it's very important because recently I'm doing more and more things with WebSockets because user shouldn't be, for instance, polling, is something ready, it's quite stupid. So if I have, for instance, if I'm doing some bigger report for user, it's for me way better to send to the browser, it's ready. And typically it's done with WebSockets. Even I have some application where everything is WebSockets. And WebSockets work well, and I would say very well with Ratpack. And what is even better, they compose well with RxJava, RxJava 2, and that's a sample. So for instance, in this game, Pong game, every time the ball moves, all these things are in fact sent by the socket. It means only because of that it's quite smooth, in fact, because if it was done by HTTP request, the movement would be like ball. So it's really great. So lessons from the Ratpack coding that I have seen. So first of all, it's a little bit different Java, and I think it's totally awesome. So really, I feel like, oh my God, I'm doing main methods, I'm doing monads, it's cool. So, but on the other hand, it's totally different than Spring Java EE. So I started with JBoss 1, and that's my 17th year with Java EE. And all this experience is gone. You can't typically use it. It even works against you. It's totally different way of coding. In my opinion, way better, but it's different. Monadic Java everywhere. That's something that you have to use that too. And it's not really complicated. A lot of people are scared about monads, but monads are really great because they really can allow you to build clean code and testable code. Simple JSON integration, that's already a cool thing about Ratpack. Very simple, and in fact, I would say meaningful tests. So you really test everything, and that's great. WebSockets, cool, and waiver. So that you don't have to use waiver with JavaSlang, with Ratpack. But I say that's my library number one, whatever I do with Java, because it's so way better than Java util collections, and you have so many goodies there. So really well done optional. Things like try either, which are way better than exceptions. Really, don't use exceptions. It's 2017. Use either. And all those things you have in waiver, and that's my default library for doing anything in Java. JDBC or blocking code is still possible, so it's great. And basically, being immutable in most part of your code helps you because your code, it's really hard to be broken. It just works. So what is not cool? There are bad things. So first of all, Ratpack was done way before Java 8 or even Java 7 was done. So at this moment, completion state or completable future wasn't part of JDK, and it means they had to invent their own promises, and they called them promises. By the way, they are based on Guava list enable future, and then in Java 8 came something that is completion stage. All those three things are basically the same. Those are promises or future container. And by the way, waiver has also future. So you have even 4. And it means in my code, I'm constantly converting from one type of promise to another. So mostly I do things with a completion stage, and finally I'm converting into to the promise that Ratpack accepts. Bad thing about Ratpack, it was initially done for a Groovy. That was the popular server inside of Groovy, and it is in fact coded with Groovy. And you will see the Groovy samples. But what is worse, in Groovy, it doesn't hurt you when every method throws exception. Because really a lot of API methods from Ratpack, they declare throws exception, which makes handling that, especially in modern Java code, stupid. But I would say I can live with that price because mostly configuration methods do that. And monads in Java. So I say monads are cool. They guarantee your code is really, I would say, safe. and easy to test. But writing a lot of monads composition with Java is horrible. So Scala, Haskell, even Kotlin have special syntax that supports monad. In Java, we don't have that. It means it looks a little bit verbose and not that nice. So there are cool alternatives. Spring 5 reactive. This is one cool alternative to Ratpack that you can try. It's something new. I would say it's the same, but done a little bit better. But don't confuse it with the old Spring. HTTP is basically alternative framework that you can use with Scala. It's very similar, I would say. They both influence each other. And Lagom. What is Lagom? It's like, I would say, it's Java EE, but with non-blocking architecture. It's alternative to Java EE. So it's way more than Ratpack because it's just whole big platform. You don't have to use, you may use it. So, but that's basically all I wanted to say to you. So my message to you, 90s are gone. Forget about servlet-based things, Java EE and Spring, because they are not cool anymore. Forget about magic, and that's all. Be simple. Try Ratpack with clean Java. Thank you.